Hello guys, so today we are going to discuss this problem, non-overlapping intervals. So the question goes like this, that given an array intervals where intervals ij is equal to start I and end, return minimum number of intervals you need to remove to make rest of intervals non-overlapping. So these are the intervals on the number line. So let me take this. So the intervals given here are these. So on the number line, if we have this number line and we have 1 here, we have 2 here, 3 here, and 4 here, right? So the question says is we have an interval from 1 to 2, we have an interval from 2 to 3, then we have an interval from 3 to 4, and we have an interval from 1 to 3, right? So here as we can see, okay, 1, 2, 3. Here as we can see, these intervals are overlapping. Three intervals are overlapping. So if we remove this interval, 1, 2, 3, if we remove this, then there will be no overlapping intervals in it, right? Because when we remove it, um, if we remove it, three intervals will remain and no interval will be overlapping. So that's the question. So how many intervals we need to remove to make the rest of intervals non-overlapping? So to solve this kind of interval related problems where we are given intervals, for example, meeting room is one problem, then there are some problems on the merging side where intervals is given and we have to either remove or solve these interval related problems. So in that case, we have an algorithm, that is we have a interval scheduling or interval greedy algorithm. So um, you can find this algorithm here. So what this algorithm says is that when we have some of these intervals and when we need to find an non-overlapping interval, for example, here the output will be 1, 2, 3 and 2, 3, 4. How we do it is we sort the input interval based on the end times. So for example, here end times is 2, 3, 4 and 3. So if we sort this array 1, 2, 2, 3, 3, 4, 1, 3, it will become this. So 2 will be first, 3 will be second, then 3 will be third, right? Rather 1, 3 will be here. So it should be 1, 3, 2, 3, and then 4 will be at end. So this moves at end. Then we have to take a temporary variable which points to the first array, that is in the sorted array. So here A1 and B1 we make it as this, and then we start comparing this element with the rest of array. So let's take this example and understand it. So here we have this array and then we sort it. So after sorting it, it becomes 1, 2, uh, then it becomes 1, 3, then it becomes here 2, 3, and then it is 3, 4. Now we take this as a temporary element, that is we take the first element as a temporary element. Here A1 is 1 and B1 is 2, and then we start comparing with the rest of the sorted array. So what we compare, we compare we compare B1 with A2. So here in this array, if we see, this will be A2 and this will be B2 separated with a comma, right? So here 1 will be A2 and 3 will be B2. So we have to compare B1 with A2. That is, this was our A1 and this was our B1. So we compare if B1 is greater than A2, right? In that case, um, this is a overlapping interval, right? Because if we see here 1, 2, is one interval and 1 3 is another interval. So 1 2 is one interval, 1 3 is another interval. So these two intervals are overlapping actually, right? And so for that case, we will increment the out, that is our variable, that the number of intervals we need to remove. And if it is not, what we'll do, we will make this a1 b1 point to the next element. So let's see that. Let's see. So if okay, let me go to the problem. Okay, so we got the problem now. Let's go to the code now and try to understand the code. Okay, so after sorting, so we have to sort this, that is 1 2 2 3 3 4 and 1 3. So after sorting, it will become 1 2 1 3 1 2 1 3, then 2 3 and 3 4. So we have defined a custom comparator. We are discussing Python code. So we have taken a custom comparator and we are comparing on the first element of it. So here we have the function sorted where we have passed the doubly link, doubly DQ or doubly list in Python, which is equal to double vector in C++, and we have passed the custom comparator. So in custom comparator, we have exclusively mentioned that we want to sort it based on first element. So if there are three elements, some for example 1 2 3, then we can pass the second element as well if we want to sort based on the third element, similarly. So then we have taken b1 as 0 1, right? So here b1 will be 2, and then we are iterating through the intervals. So we are iterating through the interval, so we'll have a2 and b2 here. So if b1 becomes greater than a2, here b1 becomes greater than a2, which is not, oh sorry, which is, b1 becomes greater than a2, so we will increment our out by 1. Out is our output variable, that number of intervals we need to remove. And if it is not, so now we move to the next interval. Here 1 2 and 2 3, here this is a2 and b2. Here b1, this one is not greater than this, so we'll move our b1 to here. So we'll move our b1 to here. So let's understand this. So okay, let's understand this quickly without wasting much time. So initially our b1 is 2 and our a2 is 1. So since b1 is greater than a2, so our out becomes 1. Then we move to the next element. So we are here now, and our a1, a2, b2 becomes this. Now our b1 is not greater than a2. So in this case, we will not increment out. We will just move our b1 here. So our b1 will move to here. That is b1 becomes equal to 3. And on the next iteration, we'll again check that is b1, this is our next iteration, is b1 greater than a2? No. So it is equal. So we will move over b1 here as well, but we have not incremented the count. So the only time we have incremented the count is when b1 is b1 is greater than a2. So that means that is the only interval where two, that is the only pair where two intervals are clashing. So in that case, if we remove one, we'll get the answer. So the time complexity of this algorithm, let me go back. So the time complexity of this algorithm is n log n, because for sorting it will take n log n, and then we are only traversing through the uh, list, which is on. So n log n plus n, and the space complexity would be o1 because we are not taking any extra list or the vector in C++ for doing it. So in C++ we can do similarly like this. I'll just explain C++ quickly as well. So in C++ we have taken a sort. So in sort, we have provided the comparator function in lambda. So we have taken the first element and the second element, and we are returning if a1 is smaller than b1. And then similarly, we are initializing b1 to the second element of the first tuple, and then finally in we are traversing each of interval using for each, and here we have taken all elements from the environment, and we are incrementing the out, and finally we are returning the out. So both are similar algorithms. Thanks a lot. Have a good day. Bye.